Aloha, my name is Chris Gallagher. Welcome to the State of Hawaii Department of Transportation's 2020 Protect Our Water Conference. I'm your moderator for this morning's session titled Housekeeping Do's and Don'ts. All sessions will be recorded and available to view on VFairs for 30 days following the conference. Presentations can then be found at stormwaterhawaii.com or on the Stormwater Hawaii YouTube channel. Please use the Q&A feature during the presentation to ask any questions you may have. At the end of the presentation, the speaker will have a few minutes to answer your questions. Without further ado, I'd like to introduce you to our speaker for this session. Claudia Akroyd. She is a construction inspector with Bowers and Kubota. Claudia is the Department of Transportation's Highway Division's independent inspector for contract construction projects and has worked in the stormwater program for DOT highways for over 12 years. She will be discussing several categories of common mistakes found during construction B&P inspections. Please help me in welcoming Claudia Akroyd. Good morning, Claudia.
Good morning. When we first started talking about the conference, they said, what do you want to talk about? And I said, I don't know, what do you want me to talk about? And we finally came to the conclusion, let's talk about some common mistakes. So this is not all inclusive of what we find during inspections, just some highlights of very common areas. Chris has already introduced me, so I'll skip that. These are the topics that we're going to talk about during this presentation. First, we're going to start with hazardous materials. There's one word for hazardous materials, and that's containment, containment, containment. And we'll get into some of these problems at a later date. Hazardous materials includes all containers of chemicals that are considered hazardous, and also various building materials such as galvanized steel, rebar, and creosote poles, to name just a few. All your containers, and this is required by OSHA, are required to be labeled as to contents with the HAZCOM or the Global Harmonizing System label. If you recycle containers, and some of them, I know contractors invariably recycle, they need to be properly cleaned and the contents disposed of, and you need to relabel them. You must have containment for all your hazardous materials, and if they are metal containers, you need to provide them cover envelopes. You'll see that in a minute. Per Appendix C of HAR 1155, Hawaii Administrative Regulations, you must prevent rainwater from contacting various building materials. You can either cover it with things like plastic or temporary roofing. In this case, the picture shows that it's under the viaduct. These are, a lot of building materials are considered what's called a point source of pollution because of, like for rebar, it's the rust, creosote poles. Creosote is a chemical. So you need to rack them off the ground and cover them to prevent contact with rainwater. The racking off the ground is to allow any water that runs through the area to run under the items. This is the genesis of proper covering of creosote poles and, in this case, galvanized steel. The picture on the upper left shows what the deficiency was. This was creosote infused poles on the ground. We can put them in the ground to hold transmission lines, but when you start collecting them, it becomes a point source of pollution. So all they did in the center side is you'll see pallets down here. Dunnage will also work. And then they covered it to prevent contact with rainwater. Rebar also has to be racked off the ground and covered. One of the things a lot of contractors will do is they will rack and cover rebar bars, but they'll forget all the scrap they've pulled out. That also needs to be racked and covered. If you're doing cages on your project, it doesn't matter how big they are, they too must be racked and covered. This picture, they used dunnage and they racked it off the ground, but it's not under the viaduct, so deficient and it's not covered. Hazardous solid waste, again, creosote poles, and also things like lead-based paint. In a lot of our paving project, we go down, we find the railroad ties, and we have to dig those up. All they need to be done is placed on plastic and covered up. This is not a full thumbs up because we uncovered it to take the picture. On the right, on the Big Island, they were redoing a bridge, one of the steel girder bridges. Beneath that, they had to remove all the lead contaminated soil. This is on a partial shot of their collection point. They put it in super sacks, covered it. It's also on a concrete pallet with a lip. You need to have the proper label of the containers per OSHA 1910-1200. If you need to provide secondary containment and appropriate size containment. By appropriate size, it needs to be able to hold the contents of the largest item you have on that containment system without overflow. Now, of course, locate them away from surface waters. If it gets to surface water, you have just really exacerbated your problem. If you have metal containers, they need to be covered or stored on an angle so rainwater doesn't collect. If you transfer some of the product to another container, it requires to be labeled, with the exception of it's transferred by the person that's going to use the material. And an example of this is curing compound taken out of the big barrels, put in a spray container. We also deal from time to time with inadequate labeling. Now, this example of inadequate labeling is not the fault of, solely the fault of the contractor. Went to a site and they had this thing called Flexilith Ready Pack 3-part unit. There are no labels on the exterior of those containment. And as you know from your HAZCOM communication, people are to be briefed on what chemicals are brought onto the site. In this case, nobody could tell me what was in there. When they went into the container, they found 3 parts of the system, and each one indicates it's hazardous. The slide on the left, the contractor got a pallet of containers. The only indication of what was in those containers was retardant was written with the Sharpie pen on the lid. So what the contractor did was print out a label for the manufacturer's item and paste it on to the container. When we talk about buckets labeled as to contents, and if you recycle them, this was something like resin cure on the left. They had used these buckets, and we use these buckets all the time because they're great to store stuff. It's not in containment. That's a deficiency. In our inspections, it's a major deficiency. What they should have done was, after they disposed of the content, was take the original label off, relabel it as to water, which was in here. It's always a good idea to cover all your materials, because if you don't, what happens is the label washes off and then we have no clue as to what's in the bucket. Containment systems, you have both commercial and contractor constructed. Some typical ones on the left, the bottom left, these serve as multiple uses. These are rubberized and the sides can be dropped for easy access, and you'll see why that's important in a moment. On the right, we have a pad that was constructed under the viaduct. Here again, metal barrels. These did not have to be covered because they're under the viaduct. And this was a contractor constructed thing for a barrel. In the bottom here was kitty litter to store bending drips. If you use a commercial or even contractor constructed, you need to use it properly. Obviously, the one on the left, they didn't get it fully on the pallet. This one in the upper right has a self-rising float. This is another example of commercial palletization. This self-rising float will rise with the level of liquid in there, but it's not going to rise if you put stuff on the float. I mentioned these things are great because you can drop these sides. There's metal stays in there, and you can bring a forklift in there. And it's also a very large capacity. The one on the left is not a proper construction because what they did is they put the plastic under the biosock they were using for the lip. Two things happen. One, it becomes disengaged from the biosock, and two, anything in here is going to run out under that biosock. On the right, you see they put it over the biosock. Now this is outside in the rainy area, so this is why we also recommend, excuse me, that you cover them. Because the minute it rains and fills that up, you have contaminated liquid in the bottom of that. Covered metal containers. On the left, they're under the viaduct, and there is a lip to contain anything on the site. This is what happens to metal containers when they're exposed to rainwater. I know there was something in this barrel because I could see it, but the label had long since also washed off. Near empty containers, you should properly store those also, because if you just toss them aside and you have a little bit of whatever hazardous material was in that container and you forget to close the stop, you're going to end up with contamination on the ground. So over here, this particular container still has about 2 inches of material in it. I'm going to talk about asphalt, concrete, and cold patch together. Both are petroleum-based products. Because they're petroleum-based products, oil will run off in the rain. Waste or stockpiles of these materials must be contained away from rainwater. Two examples of common things that I find: cold patch on the bare ground, or waste asphalt from a paving project put over on the side. Spoil piles are off limits in terms of putting in asphalt or a cold patch. What this contractor has done was contaminate all the spoils in that pile. Proper storage on an impervious material such as plastic or steel plate, cover to prevent contact with rainwater and perimeter control. If you're storing cold patch, I highly recommend you store it on steel plates. Because if you're going to bring a loader in to scoop it up, it's much easier on a steel plate. Otherwise, you might end up with a load of plastic with your scoop. Waste asphalt. This is on the drip pad for the paving equipment. It's easy to fix. You either take a couple shovels and dispose of it, or you cover it with plastic. This is a common sight. When you bring the shuttle buggy back in, the operator runs the drum and it ends up on the drip pad. Cold patch. No one was on the site. The guy delivering the cold patch came out. Okay, he had the general area, so he dumped it on the bare ground. Now the contractor has to double handle this, and they need to scoop it up, remove the contaminated soil, and store it properly. Here they placed it on plastic, covered it, and put perimeter control around it. A little bit about spoils and stockpiles. You never confuse the perimeter control with the stockpile control. They're two separate entities. You're protecting them not just for rain and runoff, but also wind erosion. Nearly all piles are coverable. And I'll show you examples of some really big piles that were covered. The perimeter protection is separate from the site protection. And if it is way too big, and I'll give an example of that, hit it with hydromulch with tactifier. This is primarily for wind erosion. If you have one that's way too big, it's probably well back in your site. This particular site drained this way, and it also drained this way. They put the spoil pile trying to conserve biosocks right next to the perimeter. As you can see, there's dirt here that would run off. Their correction was to take the perimeter further out. Here are some examples of covering. The one in the bottom is coverable. It's very large, but take a look at this one. This spoil pile back here actually goes way back to the tree line. Obviously, this mountain over here was not exactly coverable, so what they did is they hydromulched it with tactifier. Concrete used in this presentation includes all products that contain cement. We all know that concrete and concrete wash water are hazardous. It's almost as caustic as Drano. If you think about concrete, we're talking about it's a combination of cement, gravel, or rock, sand, and water. Of those four components, only the cement is the toxic element. So included in concrete and treated as concrete is CLSM for ductwork, grout, concrete treated base course, mortar, plaster, and stucco. What concrete or concrete wash is never left on the bare ground? This is not just our rule, it's also EPA's rule. I'm also going to talk a little bit about fines from grinding or saw cutting. Two types of washout, commercial or contractor constructed. I included kiddie pools in the commercial because you go out and you buy them and they're very common to be used. Assume all your washouts leak. This one on the left is a commercial washout. This back gate is caulked to prevent leaks. However, it's not uncommon for them to still leak because they continually strip off this caulking and replace it, and you get these little pukas. And in this case, it ran to the gutter and down to a drain. On the right, kiddie pools usually never survive more than one washout. Wash water is so caustic, it will make the kiddie pool very brittle, and you end up with little pukas every time you try to move it. If you want to reuse your kiddie pools, line it with one large sheet of plastic. That way you can reuse them. Contractor constructed boxes. I very rarely ever find one that doesn't leak. And here they have contained that leak, and I'll get into that in a bit. In-ground washouts. These need to be just one solid sheet of plastic in the washout. If you overlap, as this one did, what happens is the wash water runs underneath the plastic and into the ground below. This is actually constructed above ground, but you can see what happens if, and think about it, if it's in ground. Because it was not properly constructed, the wash water seeped through the soil to the surrounding area. Every contractor constructed box I've seen just about has leaked. And most of these contractors have put 3 sheets of plastic in them. What happens is the truck driver brings his boom and it's way above, and the rock in the concrete makes little pukas in the plastic. All you need to do is create a secondary containment. And this is very easy. There's no rocket science attached to this. Spread out a large sheet of plastic, burn it under the edges. It can be done with biosocks, dunnage, whatever you have on site. The one on the left did not have containment, ran into the gutter. The one on the right, you can see where it has dripped through, or the driver missed the area and is contained. It also makes for very easy cleanup when it's dried. Waste concrete on the ground. This picture on the left is actually moist concrete from a washout. They were doing tremendous concrete pours, so they cleaned out a washout and were letting the spoils dry. This would have been okay if they just spread out a large sheet of plastic and put it on the plastic. Here, it's reversed. Covering the concrete that's placed on the ground does not make it right. You need to consider the capacity of your washouts. Ensure you have enough capacity before the pour starts. You also run the risk of the estimates of the amount of leftover concrete may not be quite accurate. So you need to make sure you have sufficient capacity. If you're using kiddie pools, have a bunch more out on site. Per EPA, they should only be filled to 75% capacity. That gives you some freeboard if it rains before you can get it covered. If you're saw cutting fines, you need to vacuum those saw cut fines. If you see a lot of dust coming out of the vacuum, it means either the filter's not working, or in some cases it's not even in, because these filters clog up very rapidly. So sometimes the crew decide to leave it out. In this case, they didn't have the filter in there, but they didn't want to work in the dust cloud because it is a hazardous dust cloud with the silica in it. So they created a smokestack out of vacuum parts. In controlling dust, if you're doing a dry saw cut, a simple spray of water, and that's what this guy in front is doing, is he's spritzing the dry saw cut, and you can see there is no dust around there. There are a lot of simple attachments that you can get for various tools that you use. In this case, one of the things the contractor was doing was drilling to put in rebar or bolts. This is a simple, This is a simple device that is commercially available, and you drill through the puka and the vacuum does the rest of the work. You need to dispose properly of your saw cut fines. On the left, the contractor made sure to point out that they were vacuuming up their saw cut fines who walked to the end of the project, found them laying on the ground, exposed to rainwater. On the right, all they did was dump the stuff from the vacuum in a pan, which is fine, or you throw it in your washout, whatever. This is actually covered by an overpass. The requirements for drip protection. you need drip protection under all idle equipment. It needs to be an appropriate pan or pad or pan. The pan needs to be large enough to have a chance to catch the leaks. Under paving equipment, you're required to have drip protection. Pans don't work. So you need to have drip protection, especially under the asphalt hopper, roller assembly, and distributor truck spray arm. If you're using a crane, you need the drip protection when it's idle, and also when it's in a stationary area for several hours while you're using it. This is especially true if you're operating near or over water. That drip pad gives you a few seconds to a couple minutes time to react should you bust a hydraulic line. Spill kits should also be readily available. These are just some examples. You've got your commercial pan there. You've got what I call cookie sheet drip pans, drip pad. Here, they've pre-stationed spill kits and extra drip pans because this was on a very large site. Equipment was usually left where they were working, what I call skull type, and this is a crane. The cookie sheet pans, these are commercially available pans. They are, however, not a good choice for construction sites. What you have is a very shallow lip, and these things are very thin and very light. They have very little capacity. In order for these things to hold any drips, they must be on a perfectly level surface. They also only survive about one drive over. These things are designed for warehouses and motor pools. It needs to be appropriate and sufficient size to be of use. The one on the left, they had a leak. So what they did is they put cardboard and a t-shirt under there. Not appropriate. On the right, this is actually a commercial pan designed primarily for oil changes. They have to be extremely lucky for any drips to hit that pan. Drip pad requirements. You have to have an impervious layer like plastic, an absorbent layer, and a downslope berm. The fabric was rolled back to show the plastic. And they placed the biosock berm under the plastic. This creates a pooling effect. This has saved, by putting it under the plastic, this has saved more than one contractor who busted a hydraulic line and they had a pool of hydraulic fluid. If the biosock's on top of the fabric, it will leach through the fabric under the biosock. On the right, they didn't have anything under this equipment. It leaked on the steel plate and ran off. This is what happens to paving equipment if you don't have a drip pad under it and it rains. This picture was taken a day or two after they had had a rain in the area. It was sunny that day. Oils in the hoppers and on the roller plates create an oil slick out the back. Also, when you have a drip pad, the fabric needs to be changed when it's saturated. The fabric we commonly use on drip pads can only absorb very minor leaks. It's not designed for full absorbency. Cranes, as I said before, when idle, they need drip protection. When they're remaining in a static location, you need to have a drip pad under them that encompasses the swing radius. This is very vital when you're working near water or over water to give you time to react should something catastrophic happens. This particular pad, they have a secondary drip pan here under oil pan. This is very old Mantowoc crane. So when it does rain, the oil pan under the crane has a tendency to overflow. So they compensate it for that. Just some food for thought. The hazardous material containment system that I showed you, the rubberized pad, get them large enough. You can also use them as a drip pad. This is a maintenance truck, so you have all sorts of hoses and stuff. So they just use one of these pads. You can drop the side, run it in, put it back up. On the right, this is what I term a scroll. They cut oil absorbent pads and place them on top of buried material, took some 2x2s, stapled it to it, and if they're going to stop someplace else, they can simply roll this up, put it on the equipment, and it's right there. They don't have to go all the way back to the other area. Let's talk a little about solid waste. These are items of solid waste that I took from the DOT fact sheet on solid waste. It's any material leaves the site that is no longer usable. That includes concrete rubble, rock, masonry. We all know that. Spoil piles of clearing and grubbing waste. Green waste. That is considered solid waste. A lot of times I go to a site where they've cleared for the staging area, and I find piles of the grubbed material outside the silt fence. Not good. We already talked about asphalt and concrete slurry and washout are all considered solid waste. Trash bins are required to be covered, and they should be emptied either on a periodic basis, but in any case, when they should not be over 2/3 full. So the one on the left is overfilled, and the one on the right, they put the plastic over top of it. This is because these are not watertight, and any rainwater will wash any pollutants in that bin out to the ground. We talked about rubble. This rubble on the right has an awful lot of fines in it. So that gets into, if they don't take it out, they need to cover it and put perimeter control. And here we have all the grub material outside the silt fence. That either needs to be inside the fence, covered with perimeter control because of all the soil involved in it, or removed. Questions?
Thank you for your presentation, Claudia. We're going to open up the question and answer portion for this session. I know we have one question right now, so if anyone else has any questions, please type them in the Q&A feature at this time. So the first question is, do aggregate stockpiles require plastic or fabric sheeting under the stockpile, if not hazardous?
Okay. Aggregate stockpiles are like any other stockpile. If they have fines in them, and the way you can test this is you pick up a handful in the wind, and if you see dust blowing off, it needs to be covered. If you have large rocks that you're stockpiling, if they are clean, you don't necessarily have to cover them. Do they have to be on fabric? Not unless they're considered hazardous, like with coal, not fabric, but plastic, such as coal plane material, not coal patch, and asphalt. Those have to be on impervious material, covered in perimeter control. Hopefully that answers. And
Thank you, Claudia. And I guess we'll just give a few more minutes to see if anybody else has more questions. Okay, I guess, oh, there we go. We got a little bit more. So another question came in. What methods have you seen to capture saw cutting slurry?
Primarily, it's vacuuming. And you need a good shop vac. Um, and you vacuum as you're saw cutting. Then you should go back later on because you'll find a fine layer left on there. What you can do when that has dried is take a good stiff bristle broom um, and dislodge it and re-vacuum to get the rest of the fines up. Now, it's very telling when I walk on the site, like if they've done core samples on the roadway. I can tell by just looking at the stain whether or not they've been trying to vacuum. You get points for trying and more points for if you can't get it all up, what's your next step?
Okay, next question is, what is the most common deficiency found?
That one I cannot answer quickly because it depends on the type of project. If you're talking about a project with a lot of concrete work, it's obviously concrete waste management. If you're talking paving, it's usually something to do with the asphalt. It all stems from the type of project it is. If there's extensive use of biosock, a lot of times I'll find a ripped up biosock.
Okay. Next question is, so for the 3B fine material, as long as it is clean, it does not need to be covered?
Okay, 3B fine. Again, do the check. When in doubt, cover it. But if there are fines mixed in with it, and only rarely do I ever find a really clean pile, you should cover it and put protection around it. But if you drop it into the wind and you find fines going off in the wind, it has to be covered. We even had contractors cover boulder piles of 12-inch boulders because there are a lot of fines mixed in with it. It was not clean.
Thank you. Next question, if a machine is in use but stationary, drilled shaft, etc., is drip protection needed?
If it's a machine doing drill shaft, yes, you should put drip protection under it because it's going to stay there probably all day, especially if it's near water.
Okay. When do you ever use silt fence versus biosocks?
That's a contractor decision. Silt fence is more effective at controlling sediment runoff than biosock. However, contractors have started using biosocks rather extensively because they're easier to install than a silt fence that has to be trenched in. But there's DOH has told us when we first started, way back when in the consent decree, we can use any commercially available BMP device, provided it's appropriate to the situation and it's installed per manufacturer specs.
Okay. Going back to the slurry, is it a deficiency if you find the slurry hardened on the ground surface by the time you do your inspection?
That's hard to say. Used to have a slide where they had done some core samples in asphalt road. You could see the slurry had washed to the gutter area with no evidence of vacuuming. Other areas, you could tell they vigorously tried to vacuum, but there's still a stain. It's kind of situation dependent. This whole thing is part science, part art. Because you're not going to get it all up. You're still going to have a stain, but you got to look at the situation and see how far the slurry actually ran before they started vacuuming.
Okay. Do you,
Just one
yeah.
more note.
Okay.
DOH has cited projects for slurry that has accumulated in gutter areas.
Okay, we got about 3 more minutes left. We'll try and blow through the remaining questions. Do you see any pollutant sources that are often missed, not addressed in BMP plans, or no BMPs installed?
Yes. Not necessarily pollutants, but not doing the proper BMPs. For example, you have a road construction project and it goes from point A to point B. And at point B, you're downslope, and 15 feet away, there is an inlet. That inlet must be protected because you're responsible for anything that leaves the site. So you need to put protection in there, even though it's not part of your official project site.
Okay.
So you need to look at the surrounding area. And a lot of times when contractors do their BMP plan, they're basing it on a draft that was included in the bid documents. Those are not the BMP plan. It's a starting point to give the contractor an idea of where they need to put their BMPs. They need to build on that. That's not their plan. Anything else?
Okay, the next question is, what are the times required for the contractor to respond to a deficiency in the different deficiency categories, major, minor, etc.?
Okay. Now, I have to tell you, my criteria is based on the Oahu MS4 permit. For a correction of major minor deficiencies, it's 5 calendar, not work days, calendar days from the time the deficiency is found or prior to the next major rain event. Critical, it must be corrected by the end of the day, not the next day, the end of the day. One of my rules of inspection is life is not fair and sometimes it really sucks. Let's hope if we find it critical, it's not 2 o'clock in the afternoon.
Okay. What type of containment do you recommend for acid washing or power washing? Application surfaces could be overhead, vertical, or even with the ground.
Going back to if you're doing a lot of it, let me see if I can.
And this will be the last question. So the remaining questions, I'll forward over to Claudia, and we'll see if we can get those answered to you after the presentation.
Well, if you recall those big rubberized pallets that I showed you, let me see. Because this was actually put under the viaduct to collect these types of pallets. Oops. Here, this is the slide I was talking about. This was actually put under the viaduct while they were doing hydrodemo up above to catch any potential leaks under there. If you're doing power washing, of the overhead, you might want to think about spreading plastic around and berming it as you're doing it to collect anything that comes down from the overhead, unless you have a bunch of these laying around.
Okay, thank you, Claudia. That will now conclude this session. Thank you everyone for attending. The next session begins at 9 a.m. So please return to the sessions tab to see the next breakout sessions. If you're experiencing any technical issues, please visit the info desk for assistance. Also, don't forget to stop by and check out the vendors during the break. Thank you.